Hi everyone, my name is Mohit. I'm an assistant professor in CICS and a member of the Center for Data Science. And my primary research interests are in natural language processing and more specifically, natural language generation. So today I'm going to be talking about one of our recent projects on style transfer using paraphrase generation as the method for which we accomplish this goal. So this is text-based style transfer. For example, taking a sentence written by William Shakespeare and transferring it to another sentence which has the same content but might be more in like a Twitter style, for example. And so this task has a lot of real world applications, which I'll get into a bit later. But this project was presented at EMNLP 2020 just last year. And all of the code, the data we used, and a live demo of our models are available at style.cs.umass.edu. So please do check it out if you're interested. Okay, so what exactly is unsupervised style transfer, which is the task that we're tackling here? So first of all, the most important word in this term is style. So what exactly is style when we're talking about a piece of text? And we use the following definition. So the style of a text refers to the patterns of lexical and syntactic choice, which are distinct from the content of a sentence. So when I say lexical choice, that means what kinds of words did I use to express a particular meaning? Were they, simple words that a general audience could understand, or were they more uncommon words that maybe speak to a different audience? And similarly, syntactic choice refers to the structures of the sentences, right? Do I use a sentence with a lot of different clauses, or do I prefer many short, simple sentences instead? These are examples of syntactic choice. And note that we are making an assumption here that these patterns are distinct from the semantic meaning of the sentence. In other words, there are many different styles in which one could express the same meaning. And you could drill down deeper into what these patterns might look like. Some examples are, does an author use passive sentences more or active sentences more? How many adjectives did they use for every noun that they use? How many rare words did they use, etc. They're more like high-level definitions or aspects rather of style, like how formal is a particular sentence, how simple is it. Ed Hovey in 1987 detailed a bunch of other aspects of style that are certainly relevant. So before moving forward, I just wanted to say that the definition of style that we are using is not universally accepted in sociolinguistics. In particular, many researchers have expressed that style cannot just be defined as these kinds of surface level manifestations of some desired way to convey information, right? It's actually linked to the context, the social context in which the sentences are being uttered or written, and so we acknowledge that our definition of style kind of does focus specifically on the fact that it can be isolated from content as a surface form. But even our definition of style unlocks real world applications if you can do style transfer in this way. So let's move on then to the task of style transfer. Basically, we have an input, and here we're focusing exclusively on sentences. We have an input sentence, and we have a target style. So we'll see many different examples of what these styles could be. For example, it could be tied to a particular author, right? Like write something in Shakespeare style, or the style of Twitter, or the style of some average American in the 1850s. and we produce an output sentence which preserves the meaning of the input approximately, but also has stylistic attributes that are relevant to the target style. So our goals are the input and output should semantically be very similar. They should be approximately paraphrases of each other. And an example, just to make things more clear, is the following input sentence: "Oh, wilt thou leave me so unsatisfied," which is from Shakespeare. And we can style transfer this over to something like Twitter speak by having our model produce something like, "Oh, you will leave me so sad, question mark, sad face." So you can see that, of course, some aspects of the meaning have been warped here, but overall, it's done a fairly good job at preserving the at least high-level semantic content of the input sentence. Okay, so what does the unsupervised part here mean? That means that we don't have any access to paired data between two styles, right? It's very unreasonable for me to expect that somewhere out there someone has translated all of William Shakespeare into Twitter speak, although maybe people have done this, I don't know. But in general, like, especially if we're dealing with many different styles, it is unreasonable to expect paired data, like parallel data between two styles. So we might have a lot of data in one single style, right? We might have all of these sentences from Shakespeare and all of these sentences from Twitter, but we don't have the corresponding transferred versions. And this is where the unsupervised aspect comes in here. So our work here is kind of a direct response to previous work in NLP that focuses on style transfer. This has become a very popular subfield over the past couple of years. And one of the major issues with this recent work is that the models significantly modify the content of the sentences. So their output might be stylistically similar to the target, but they also modify the content. So it's not actually doing style transfer. And here are some examples from one existing style transfer paper in which we see that in this example, they were changing the style from relaxed to annoyed. And the sentence, the input sentence, "sitting by the Christmas tree and watching Star Wars," was transferred to "sitting by the computer and watching The Voice." And if you read these sentences, you can see that they're nowhere close to being paraphrases of each other, right? The content has completely changed. And we can't really say that these are instances of style transfer. One thing that has been noted is that, we have in two different stylistic corpora like Shakespeare or Twitter, not only stylistic differences, but also content differences, right? On Twitter, we might see, tweets about politics or current events, or we might see things like hashtags, which of course weren't even a thing when Shakespeare was writing. And so Shakespeare also has some terms that he uses that are, obsolete at this point. So there's significant difference in content as well as style, which kind of contributes to the challenge of this unsupervised style transfer task. And so let's briefly take a pause here to talk about some real-world applications of this kind of style transfer thing. So it's not just some kind of novelty task, but rather it can be very useful for real-world tasks such as text simplification, right? Translating something that is complicated into something that's simple and more for a general audience. Data augmentation is another area in which this kind of thing can be very useful. So taking some training data and augmenting it with data that has been transferred into from a different style. There's other things, writing assistance, evaluating text generation systems, and making your models more robust. Okay, so our paper does a lot of different things, but I wanted to focus on our algorithm, which is the state of the art for this task and uses paraphrase generation as a way to accomplish it. So how do you transfer style while preserving semantics, given that you don't have parallel data between two styles? So let's take our Shakespeare and Twitter example. What I really want is, if I wanted to train some sort of neural language model, which is what all text generation models at this point are based around, I would like to have some input and output. And in this task, I would like to have a sentence that has the same content as one of these Shakespearean sentences, but is in a different style, right? So paraphrase that is without the stylistic signal from Shakespeare, and I want to translate those essentially into Shakespearean style. Unfortunately, I don't have paraphrases that of these sentences that are in a different style. So how do I actually get this data? And the way that we tackle this problem is by creating what we call pseudo-parallel data, which I'll explain on this slide. So let's take this sentence, "Thou chidest me oft for loving Rosaline." This is an original Shakespearean sentence. Now I'm going to apply a model that we call a diverse paraphraser. So it's going to take this sentence as input, and it's going to translate it into something that kind of normalizes the style. So it's going to remove anything that is stylistically dissimilar to like modern mainstream English. So we can see that the sentence became, "You've always been kind of mean to me for liking Rosaline," which is doing a pretty good job at preserving the meaning, but you see that lots of things have changed about this sentence, right? The thou has gone to you, chidest me has become kind of mean to me. So lots of changes have happened here. And now we are going to go from this diverse paraphrase to back into a Shakespearean sentence using what we call an inverse paraphraser. And so we're going to train another model to go from this kind of style normalized sentence back to the original sentence. So in this way, the most crucial component of this model is the diverse paraphraser, which we implement through a model trained on the output of machine translation systems. So I won't go into too much detail on that, but note that during our training process, we're going from Shakespeare to a style normalized form and then back to Shakespeare. So how do we actually use this process to go from Shakespeare to something like Twitter? This is what happens at test time during inference time. So this is what I have during training time. And at test time, I'm going to swap out the inverse paraphraser that I've trained on Shakespeare for an inverse paraphraser that I've trained on a different style. So let's say I swap it out for one trained on Twitter. So the process looks like, if I have a sentence, "Oh, wilt thou leave me so unsatisfied?" I apply this diverse paraphraser to get something like, "Oh, you're going to leave me unsatisfied, right?" Then I apply the Twitter inverse paraphraser, which takes this style normalized output and translates it into something like, "Ooh, y'all will leave me unhappy, LOL," which is clearly more similar to Twitter style. Okay, so back to the diverse paraphraser. This is a little more technical, but we train it on, as I mentioned, the output of machine translation systems. Specifically, there's a process called back translation in which I might go from an English sentence to a sentence in a different language. We use Czech here, so we go from English to Czech and then back to English. And in doing this back translation process, we introduce some noise into the output that we get. And oftentimes the output English sentence differs from the input English sentence in lexical or syntactic choice. And we can filter this back translated data to get just paraphrase pairs that are they're diverse syntactically or lexically, which helps us use this in our pipeline. So at the end of the day, we call our model strap style transfer via paraphrasing. And yeah, I've already explained the process by which it works. So an implementation note, we implement both the diverse paraphraser and the style-specific inverse paraphrasers by fine-tuning a GPT-2 large language model. So this is a pre-trained language model released by OpenAI. It's been pre-trained on billions of words of text, and it's a great place to start if you want to start from something that produces fluent text. Okay, so I just wanted to give a quick note about how we actually evaluate our model. So remember that it takes an input sentence and a target style and produces an output. So there's 3 different metrics that we use. One is accuracy. So does the output have the target style that we want? Another is similarity. So this is testing whether the meaning has been preserved between input and output. And a third is fluency. So is the output grammatically correct? And so I'm not going to go into too much detail on how we implement each of these metrics, but I will say that we aggregate them into a single score to have a single way of comparing our model to other systems. And just some quick highlights from our evaluation. Our strap method significantly outperforms prior work on 2 different data sets. So one is formality transfer, so going from formal English to informal English. We see 2 existing baselines for style transfer, and the aggregate scores here are much higher for our model compared to these baselines. In particular, and in this task, we go from Shakespearean English to modern English, and we see the same kind of gap. Our model is significantly better here. We also do a human evaluation, so we ask humans to rate the both the accuracy and the similarity here. And we see that our model is much better here. In particular, most of its gains are coming from similarity, meaning that it's doing a much better job of paraphrasing the input sentence compared to the baselines, which don't really have any constraints to make their output as similar in meaning to the input as possible. So I wanted to kind of wrap up with some examples. I didn't mention this, but we also created a new data set with like 12 different or 11 different styles and many different pairs that you can look at. So Twitter to Shakespeare, as an example, y'all kissing before marriage. This was the input sentence, and we translated it over to Shakespeare, and it said, and you kissed before your nuptial. So you can see that it's doing a good job at syntactically and lexically capturing some elements of Shakespearean style. It also works fairly well on longer sentences. As an example, let's take a look at, I don't know, this one. So this is translating a sentence written in 1990 to the common writing style of 1810. This is in America. He was terrorized into making a statement by the same means as the other so-called witnesses. And in 1810, if you wanted to write this sentence, well, our model produces, terror had been employed in the same manner with the other witnesses to compel him to make a declaration. So you can see that it's doing a fairly good job at preserving the meaning and also transferring the style. This is not to say that our model is perfect, but it is doing a fairly reasonable job. So just wanted to wrap up, I probably said that before, but for real this time, on some cases where our model fails. One error case is that it misunderstands kind of rare words that are style specific. So when you translate, for example, from Shakespeare to the Bible, our input sentence, have you importuned him by any means? I think importune means something like harass. But our diverse paraphraser translates this into import, and then our output also uses that same definition. So it's kind of warped the meaning here because it didn't understand what this word meant. Another error case is where it drops semantic content. So an input sentence, the machine itself is made of little straws of carbon. The diverse paraphraser just ignored the carbon part, and then we got something like machine made of straw, which obviously is wrong. Sometimes it just hallucinates random stuff, which is a common problem with all of these kinds of neural language models. And of course, hopefully they improve in the future. All right, so that's all I wanted to say. And again, you can check out our models and a live demo at this URL style.cs.umass.edu. Thanks.